In this video, I will walk you through free response question number 4 from AP Calculus Practice Exam 1. In this problem, we will practice finding derivatives, integrals, and tangent lines. But in the most interesting problem, we will prove whether function g is continuous at x equals -3 using the definition of continuity. If you have not yet watched free response questions number 1 through 3, you should probably watch those first. You can either click the link that appears in the upper right-hand corner or find the link in the description. The function f is defined by f of x equals the square root of 25 minus x squared on the interval from -5 to +5. Part A. Find f prime of x. Let's think of f of x as 25 minus x squared to the 1/2 power. So to find f prime, we will simply use the chain rule. First, we take the derivative of the outer function. So the 1/2 comes to the front. Subtracting 1 from this, we have the -1/2 power. The inside part stays the same. However, the chain rule demands that we multiply by the derivative of the inner function. The derivative of -x squared is -2x. Let's simplify this a tiny bit. 1/2 times -2 is just -1. So we can write f prime of x equals -x times 25 minus x squared to the -1/2 power. Or we could write f prime is equal to -x over the square root of 25 minus x squared. We should also include these domain restrictions, which still remain. Part B. Write an equation for the line tangent to the graph of f at x equals -3. Whenever they ask me to write an equation of a tangent line, I always use point-slope form because it reminds me that all I need is a point and the slope. Since they are asking us to find the equation of the tangent line at x equals -3, we know that the x-coordinate of the point of tangency is -3. So all we have to do is find the y-coordinate, which will simply be f at -3. So that will equal the square root of 25 minus -3 squared. This turns out to be 4. So the point of tangency is -3, 4. How about the slope? In a calculus class, we know we can find the slope at a point using the derivative. So we just need to evaluate f prime at -3. F prime at -3 looks like this, which simplifies down to 3/4. So the slope of the tangent line is 3/4. Now we can write the equation of the tangent line, which goes y minus y, so y minus 4, is equal to the slope times x minus x. Since x is -3, we wind up with x plus 3. So that's it for part B. Part C. Let g be the function defined by this piecewise function. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. According to the definition of continuity, if g is continuous at x equals -3, then the limit as x approaches -3 from the left has to equal the limit as x approaches -3 from the right, which must also equal the value of the function at -3. So, in order to prove that g is continuous at x equals -3, let's find each of these 3 values and show that they are all the same. Let's start by finding the limit as x approaches -3 from the left. To the left of -3, we are in this interval. So this piece of the piecewise function applies. Remember that in the setup of the problem, we are told that f of x is equal to the square root of 25 minus x squared. This limit can be found by direct substitution. So let's plug -3 in for x. This simplifies down to the square root of 16, which equals 4. Now let's find the limit as x approaches -3 from the right. To the right of -3, we are in this interval, so this piece applies. Again, we can find this limit by direct substitution. Putting -3 in for x gives us -3 plus 7, which equals 4. So far, so good. For the last part of the definition of continuity, we need to find the value of g at -3. At x equals -3, we are going to be dealing with the top piece of the piecewise function because of the or equal to part in the domain. Remember that f of x is this function, so we're going to evaluate this at -3. In other words, the square root of 25 minus -3 squared. And yes, this is the exact same calculation that we did in the first step, but for the AP graders, we need to write it out again, but this time calling it the value of the function at -3. But notice that we get the same value all 3 times. Check, check, and check. For the summary statement, we say g of x is continuous at x equals -3 because the limit as x approaches -3 from the left equals the limit as x approaches -3 from the right, which equals the value of g at -3. Part D. Find the value of this definite integral. Let's do a little u substitution. Let u equal the stuff under the radical, so 25 minus x squared. In that case, u prime will equal -2x. Let's do the substitution. Notice that I am leaving off the limits of integration. That's because I have introduced this value of u, but these limits are values of x, so we cannot mix x's with u's. I will bring back the limits of integration at the end of the problem when we replace this u with a function of x. Meanwhile, instead of dx, we write du divided by u prime, so du over -2x. And then we notice that we have an x in the numerator and another x in the denominator. So these cancel each other out. We still have this -2 in the denominator. This will end up as a -1/2 out in the front. So we have -1/2 times the integral of the square root of u du. Let's look at the square root of u as u to the 1/2 power. So time for the power rule of integration. Adding 1 to this exponent, we get u to the 3/2 power. Then we divide by the new exponent. Dividing by 3 over 2 is the same thing as multiplying by 2 over 3. Don't forget about the -1/2 that we have out in the front. And do not forget your plus c. These 2's will cancel each other out. So we have this. Let's substitute 25 minus x squared back in for u. And also, let's bring back the limits of integration. So we have -1/3 times 25 minus x squared to the 3/2 power. Put a vertical line and apply the limits of integration from 0 to 5. This means we need to find the value at 5 minus the value at 0. So here is the value at 5 minus the value at 0. Since we are subtracting a negative, we can replace this with a big old plus. Notice that we have 25 minus 5 squared. In other words, 25 minus 25. So this is just going to be 0. This whole term is going to become 0. So we really just have whatever this is. On a free response question, this is a perfectly acceptable answer. However, the 3/2 power means power over root. So what we have here is the square root and then the third power. So we could simplify. If we take the square root of 25, we get 5. So this is another version of the answer. If we cube the 25, that is 125. So another version of the answer is 125 over 3. Kabam!